Number 10.
Number 10. Okay. Since it's number 10, can I do a little bit to show your colleagues other questions and then we'll get to 10? I promise you we'll get to 10.
Okay.
So sorry. Okay. So let's start with one for before we just a warm up and then we'll look at the rest. So blah 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 is the distribution of sample proportions with all samples having the same sample size n taken from the same population. Anyone?
Sampling distribution?
Of course, that's what we are doing. That's the whole chapter on the sampling distribution. Perfect. Okay. Okay, let's also work on this. The denoted by p hat. P hat is the proportion of whatever we're looking for in the sample. So it's X, the number of successes, the number of people with the particular characteristic we're interested in, divided by the sample size. So let's see what they want. Which one do we choose? Population, sample, or standard?
Population.
Careful. It comes from the sample. P hat, no, that's okay. That's why it's okay. That's why we discuss these things. So this comes for P hat is from the sample. I collect the sample, I count the people with dark eyes, that's X, and divided by the sample size, and that's N. What are we trying to do? Which one do we select?
Proportion.
Of course, that's what we're doing. It's not variance, it's not error, it's not deviation, it's not mean. Of course, we are talking about proportions denoted by P hat. So the sample proportion denoted by P hat is given by the formula. And we already mentioned the formula. So what do you think?
X over N.
Sure. Thank you. Where X is the number of individuals with a specific or specified characteristic in a sample size of N individuals. Good. Okay, what does the sample mean? So what would be the sample mean?
C, yeah.
So the mean of a particular sample drawn from a population. The mean of values for a statistic, no. A value of the mean that's a statistic, no. The mean of values of statistic for a statistic for all possible samples, no. The sample mean is what I get from one sample. That's it. Good, excellent. What is a sample proportion?
C.
So obviously B makes no sense. So a fraction or a proportion, correct, with which some value for a statistic occurs in all possible samples. Of course, it makes no sense. A fraction or percentage with which some variable occurs in a sample. And the last one, with which some value for a statistic occurs in multiple samples. Okay. So it's good to also read the rest. See, that's why I insisted. It's very important to know all these annotations. That is important. Okay. How do we denote the sample size?
N.
Good. How do we denote the population size? Say it again.
The N capital.
Very good. What is the sample mean denoted?
X bar.
Excellent. What is the population mean?
U.
Exactly, the Greek letter. Good. What about the sample standard deviation?
Is it S?
Of course, thank you very much. The population standard deviation.
Sigma.
Excellent. Sample proportion. Sample proportion.
P with A?
Yes, p hat. Very good. P hat. Population proportion.
P.
Excellent. Well done. Good. Okay. Is the statement below true or false? The mean of the sampling distribution of p hat is p.
True.
Of course. Of course. Good. The standard deviation is this or this or both.
This too is true.
Very good. Both are correct. Okay, so let's work on number 6. Consider sampling distribution with p equals 0.11. Samples of size n. So the sample sizes are given here. Using the appropriate formula, find the mean and the standard deviation of the sampling distribution of the sample proportion. So let's choose one and then jump to problem 10. Which one would you like to work on? The easiest one is A, so we don't have to jump because, yeah. So n equals 5,000. Good. So they're asking us to find the mean and the standard deviation for P, right? Find the mean and the standard deviation of the sampling distribution of the sample proportion. Good. So let me stop sharing. So we know that P hat, the sampling distribution of the sampler proportion, is going to be normal only if, right, we have two conditions here. So let me rewrite the conditions on the side. NPQ has to be greater than or equal to 10. So this will be normal if these two conditions are fulfilled. And N is less than or equal to 0.05 of N. So they're not telling us, let me go back for a second to the problem. They're not telling us anything about the population size. So I'm assuming we have to assume that we are sampling less than 5% of the population size. That's what this means. So one more time, this second condition is sampling or taking samples from a population, but the sample size is less than 5% of uppercase N. This is what it means, that we are sampling less than 5%, so they are independent and so on and so forth. Okay, so we have to assume this one, but this one I have to check. I have to check always to make sure that I can use normality, because if I can use normality, then I cannot apply this concept. Okay, good. So let's do that first. I'm going to do it here so that I don't switch again. So I have N, which is 5,000, and I have P, which is 0.11, and I have Q, which is 0.89. So yes. And I got 489.5, which is definitely greater than 10, so I'm okay. I can use normality. So then we continue. So I have P 0.11, comma, and the standard deviation has to be PQ, so P 0.11, 0.89 divided by the sample size, which is 5,000. So all I have to do is just calculate that. Okay, So I'm just going to calculate this. I'm going to enter this as is, and I'm going to calculate. So careful. The square root, I always put parentheses because I don't know what type of calculator you have. Some calculators don't need that anymore. So 0.11 times 0.89 and divide by 5,000 and then close the parenthesis and press enter. And I got that sigma for p hat, this number, is 0.0044. So now we can go back. Let me share my screen. Okay, the mean is, as we know, 0.11. Okay, and the standard deviation is round to 4 decimal places. I knew it. Good. So now let's finally look at 10. Yes, that's fine. Are you sure you want to leave? Yes, yes. I'm positive. Okay. So let's take a look. According to a survey in a country, 36% of adults, so I'm on page 4. So P equals 0.36. Do not own a credit card. So P, okay, and Q, 0.64. Okay, so these do not own a credit card. Suppose a simple random sample of 500. So N equals 500. Complete parts A through B through D below. Okay, describe the sampling distribution of P hat, the sample proportion of adults who do not. Choose the phrase that best describes the shape of the sampling distribution. So we have to stop for a moment. And remember, there are two things here. Number one, NPQ has to definitely be greater than or equal to 10. And number two, N has to be less than or equal to 5% of the entire population. So of course that this is already fulfilled. I know that because 5%, I'm sure the population has more than 1,000 people, right? So this is already fulfilled. It's an entire country. I don't know, maybe there is a country with 1,000 people, but I doubt. Okay, so now NPQ has to be greater than or equal to 10. So N, 500, P, 0.36, Q, 0.64. If this number is not greater than or equal to 10, I cannot use what is next, what follows next. 500.36, 0.64. No, 0.64. 500.36, 0.64.
I have the number.
Yes, I'm ready.
It's 115.2.
Which is definitely greater than or equal to 10. Both conditions are fulfilled. I can use normality. So now I will write that P hat is normal with the same mean, 0.36, and the square root of PQ divided by 500. P, Q divided by 500. Okay, so I'm going to share now, and let's finish it up. Not normally because, approximately normal because, not normal because, approximately normal because. What do we choose?
D.
D as in dog. Very good. Do we all agree? Yes? Everyone?
Yes.
Okay, let me reach my laptop 1 second. Sorry about that.
That is the only question I got correct on this.
But that's okay, no worries. That's why we're here. Thank you for sharing. Determine the mean of the sampling distribution of P hat. So can anyone give us the mean? Anyone?
Isn't it just P?
Yes. Which
So-
is
0.36.
0.36. Good. Determine the standard deviation. We did not determine it,
I have the answer for that.
Okay.
It's 0.0215.
So let me stop sharing for a second. This is what we need to calculate. The square root of this times this divided by 500. Okay, so if it is 0.215 round to 3 decimal places, then we move on.
I'm sorry, it's 0.0215.
That's okay. I my fault. 0 it is.
You have to round it to 0.2022.
Yes. My fault again. Very good. Okay. So correct answer that, yeah, let me calculate this for a second. No worries. No worries. So the square root 0.36 times 0.64 and divide by 500. I got 0.02146. So indeed, to 3 decimal places, this will be 0.021.
Oh, I'm sorry, I rounded to 4.
No worries, no worries. Okay, what is the probability that in a random sample of 500 adults, more than, okay. More than 39%. So we want the probability that P hat is greater than 0.39. Do not own. Okay, so let me stop sharing. Since we know it's normal, P hat is normal, I have to use binomial CDF from the leftmost point till the rightmost point, which is infinity, comma, 0.36, comma, 0.021. And that will give us the answer. So, I'm sharing.
You say normal CDF?
We never use number PDF.
It's CDF?
It's always CDF.
Yeah.
Yes.
So instead of binomial, it's normal CDF?
Of course, normal. I don't even know why I wrote binomial. Thank you so much. Thank you. I did not lose my mind, I hope. Okay. Of course, we are talking about normal CDF. Thank you. So the lowest, 0.39. I would have not chosen the binomial, but I did write that. Thank you. So mu, 0.36. And sigma, 0.021. Again, from the leftmost point till the rightmost point, 0.36, yes. And sigma, 0.021, yes. Okay, so the probability is 0.07656. Now let's see what they want. Round to 4 decimal places. 0.766. 0. Where am I? In the air again. 0.0766. 0.0766. Okay. Interpret this probability. If 100 different random samples of 500 adults were obtained, one would expect you will have to multiply this by 100. So 7.66, round to the nearest integer. Oh, so they want 8. 8 to result in more than 39% not owning a such and such. So 100 multiplied by this. So it's 7.66, which rounds up to 8. Then we have part C. What is the probability that in a random sample of 500 adults, between 34% and 39% do not? So here, this is an in-between situation.